In this video we will introduce our paper, High-Resolution and Arbitrary-Sized Chinese Landscape Painting Creation, based on generative adversarial networks. Landscape painting is an important creative form in traditional Chinese art with a long history. Previous studies on Chinese landscape painting generation, based on image translation or style transfer, rely too heavily on conditional inputs, such as photographs or pre-prepared sketches, which constrains the content and quantity of generated paintings. To generate Chinese landscape paintings without conditional image, she proposed the first end-to-end Chinese landscape painting creation model, named Sketch and Paint GAN. However, Sketch and Paint GAN can only generate low-quality landscape paintings of a fixed size, which are quite different from real landscape paintings. To further improve the quality of Chinese landscape painting generation, we introduce a modular landscape painting creation system. The system consists of 3 cascaded modules: generation, resizing, and super resolution. The generation module first generates a square-shaped painting, then the resizing module predicts an appropriate aspect ratio for it and performs resizing. And finally, the super resolution module is used to increase the resolution and improve the quality. After training each module with the images we collected from the web, our system can create high-resolution landscape paintings in arbitrary sizes. We called 13,970 traditional Chinese landscape paintings from online art websites, search engines, and electronic museums. About 40% of the landscape paintings we collected contained ancient poems. If we use landscape paintings with ancient poems to train the generative model, the model will generate textures similar to ancient poems on the image, but it is not semantically readable. So we need to remove ancient poems from the original image. The ancient poetry removal method we adopt first determine text pixels in a coarse-to-fine manner, and then use the non-pixels to repair them. Specifically, it consists of the following 3 steps: text area detection, text segmentation, and text pixel repair. This method can achieve considerable results and does not require human-labeled training data. Figure 5 shows 2 examples of ancient poetry removal. From left to right are input image, text area mask, text pixel mask, and output image. We classify the training images based on their aspect ratio. Specifically, we classify images with aspect ratios in the range from 0 to 0.5 as class 1, images with aspect ratios in the range from 0.5 to 1 as class 2, and so on. In this way, we divide all training images into 5 categories. Table 1 shows the number of corresponding training images under different categories. We then trained a conditional generative adversarial network based on the classified landscape paintings. The training images are resized to same resolution for normalization, but their original aspect ratio bins will be used as conditional input to the discriminator and generator. Considering that the training images under each category are at the 1000 level, which is relatively limited, the generative model we choose is Style GAN 2 with adaptive discriminator augmentation mechanism, which can effectively prevent the discriminator from overfitting and generate excellent results with limited data. In order to generate paintings with different aspect ratios, we use the resizing module to predict the exact aspect ratio of the image and resize the image according to the prediction. The aspect ratio prediction model used here is a multi-layer fully connected network of pyramid structure. The input of the model is the image embedding extracted by the pre-trained ResNet 50 network, and the output of the model is the aspect ratio of the image. We trained the aspect ratio prediction model on the dataset shown in Table 1. We use the trained model to predict the aspect ratio of the landscape painting output by the generation module, and then resize the image according to the predicted aspect ratio. When resizing, we first fix the long side of the image and then use a linear interpolation algorithm to adjust the short side to fit the predicted aspect ratio. To further improve the resolution and quality of the generated paintings, we train a super resolution model that can effectively remove noise and increase resolution. We select 1150 high-definition and high-resolution images from the collected data for model training. These images are crawled from online museums and have 2000 pixels on at least one of the axes. Here we adopt IJCAI as the model architecture. In addition, we use a high-order degradation process to model practical degradations and utilize sync filters to model common rimming and overshoot artifacts. The super resolution model trained with synthetic data is able to enhance details while removing annoying artifacts for the generated landscape paintings. Here are some paintings generated by our system. We can see that the results generated by our proposed system can achieve high resolution while maintaining excellent continuity and integrity. Moreover, our system can generate paintings with different aspect ratios. Finally, let's make a conclusion. In this video, we propose a multi-stage creation system for ancient Chinese landscape paintings. The system first uses a conditional generative model based on the Staligan 2 architecture to generate paintings with specified aspect ratio intervals. Then the system adjusts the size of the painting through the resizing module to obtain paintings with different aspect ratios. Finally, the quality and resolution of the paintings are improved by the super resolution module based on IJCAI. Our proposed system can generate high-resolution and arbitrary-sized landscape paintings.